Okay, let me go over problem 1 on 8.9 part 2. Okay, so again, ideally you should probably turn off this video, try the problem, and then come back and see how you did. All right. Okay, so 1A. All right, so what must be proved in order to prove the base case? Right, so to prove the base case for a proof by structural induction, we have to prove that the property we want to prove is true. We need to prove that for the initial case. So 1A, we need to prove P of lambda. And that is that lambda has no B before an A. Okay. Part B. Okay, so in part B, remember how this works. We say, suppose X is already in S. Suppose X and S has the property. So you suppose X and S, assume P of X, which is that X has no B before an A. All right, so for recursive rule 1, recursive rule 1 says that if X is in S, then AX is in S. All right, so Y is equal to, all right, so the idea, right, is that we assume Y was created by applying one of the recursive rules, either recursive rule 1 or recursive rule 2, to X. So, right, we assume that X is in S, and that Y came from applying the recursive rule to X. Okay, so recursive rule 1, Y would be AX, or Y would be XB. Okay, so the inductive assumption in both of these is P of X, is that P of X is true. X has no B before an A. No B And in both of these, you're trying to prove the same thing. Well, you're trying to prove the same thing, but for different cases, right? You're trying to prove P of Y, where Y looks like this in recursive rule 1. Trying to prove P of Y where Y looks like that in recursive rule 2. This is that Y has no B before an A. All right, so now let's just think about real fast why this is true. Okay, now if we were to create some of the strings in S, our initial case would be lambda. This is the initial case. And now notice, okay, there's no b before an a, right? There's no b that comes before an a in there because there's nothing there, right? Okay, so the recursive rule, let's see, applying recursive rule 1 to lambda, we get a lambda, or just a. Or we get lambda b, which is just b. Okay, so that's recursive rule 1. Okay, applying the recursive rule again, we get, now this is our x in the recursive rule, so we get ax, or sorry, aa, my bad, aa. Or we get ab. B, we get, this is like our x in the recursive rule, so we get AB, or we get BB. That was my neighbor. All right, applying the recursive rule, right, we get, let's see, you get AAA, right? Or you get AAB. Here you get you get A before AB, or you get ABB. Here you have AB. Let's see, you get AB, and then you apply an A in front of it, or you get AB and then put a B after it. Either you put an A before it or you put a B after it, right? Put an A before it or put a B after it. B, B, B. All right, and you notice that none of these have, that all of these strings satisfy this property, right? That there's no B before an A. All the B's are tacked on at the end. Yeah. All right, kind of a silly property to prove, but can't give you the hardest ones right out the gate. Okay. All right, now let's just think about why this is true with, all right, so lambda definitely has no B before an A. All right, if we assume that x has no B before an A, putting an A on the end of something that has no B before an A isn't going to change that, right? And the same idea with this, right? If x has no B before an A, if there's no B's before A's in x, then putting a B on the end isn't going to change that. That's the idea.